Ionic compounds and bonding. You will be able to understand ionic bonding, name ionic compounds, and predict their chemical formulas. First, we want to look at how to name ionic compounds. Naming cations is easy. The name of the ion is the same as the name of the neutral atom. Now to name anions, the name of the anion replaces the ending of the neutral element with "ide". For example, chlorine becomes the chloride ion, or oxygen becomes the oxide ion. These are some common anions and their charges. An ionic compound is a chemical compound composed of cations and anions. When you name ionic compounds, be sure to say the cation first and then the anion second. For example, sodium is the cation, chlorine is the anion. The compound that they form is sodium chloride. Aluminum plus oxygen gives you aluminum oxide, and magnesium plus sulfur will give you magnesium sulfide. Let's predict the formula for sodium and chlorine. We have the sodium cation, and what it's going to do is going to lose an electron, getting a positive charge, Na+. Now the chlorine ion, the anion, will gain that electron, giving it a negative charge. We have one sodium, one chlorine, therefore our formula is NaCl, and we say that as sodium chloride. Calcium and oxygen. So we have calcium as a cation, oxygen as the anion. Now calcium has a charge of 2 plus because it lost 2 electrons. Now those 2 electrons are going to be gained by the oxygen anion, which is negatively charged. We have one calcium, we have one oxygen, giving us a chemical formula of CaO, calcium oxide. Magnesium and chlorine. Magnesium cation will lose its 2 electrons. Now, the chlorine anion will gain one of the electrons, but where does the other electron go? Well, we have another chlorine anion which will gain that electron. We have one magnesium, we have 2 chlorines, giving us a formula of MgCl2, magnesium chloride. Potassium and oxygen. So let's start with the oxygen anion. It has a charge of -2, which is a larger magnitude than the charge of +1 for potassium. So we're going to start with that. It's going to gain 2 electrons, like so. And potassium cation will lose an electron, but another potassium cation will lose its electron also. So we have 2 potassiums, we have 1 oxygen, giving us a formula of K2O, potassium oxide. Lithium and phosphorus. So we're going to start with the phosphorus anion with a charge of -3, which is greater magnitude than the charge of +1 for lithium. The phosphorus anion will gain 3 electrons. Each of the 3 electrons is going to come from a lithium cation. Each lithium cation loses 1 electron. We have 3 lithiums, we have 1 phosphorus, giving us a formula of Li3P, lithium phosphide. Gallium and fluorine. We'll start with gallium, which has the higher magnitude of charge with +3. Fluorine only has -1. Gallium is going to lose 3 electrons. Now each of those electrons will be gained by a fluorine anion. So at the end we have 1 gallium, we have 3 fluorines with a formula of GaF3, gallium fluoride. Aluminum plus oxygen. This is a more difficult one. We'll start with aluminum because it has a higher magnitude of charge with +3. It's going to lose 3 electrons. Now the oxygen, the anion, is going to gain 2 of those. So where does that third one go? Well, that is gained by a different oxygen atom. But the oxygen, remember, it gains 2. So oxygen is going to gain another one. Now where does that other one come from? Well, there must be another aluminum cation, which is losing electrons. But the aluminum loses 3. So where do those other 2 electrons go? Well, there's one final oxygen anion that can gain those last 2 electrons. Therefore, overall, we have 2 aluminums, we have 3 oxygens for a formula of Al2O3. Now, there's a shortcut to actually getting the right formula, and we can do that simply by crossing the charges. For example, aluminum and oxygen. That was a really difficult one, but with the shortcut, it's easy. We see that aluminum has a charge of +3. Well, that +3 is going to go into the bottom right-hand corner. Oxygen has a charge of -2. That -2 is going to go into the bottom left-hand corner, and that gives us Al2O3 aluminum oxide. Gallium and fluorine. As we can see, gallium has a charge of +3, which is going into the bottom right-hand corner, and then fluorine has a charge of -1, which is going to go into the bottom left-hand corner, giving us GaF3 gallium fluoride. Lithium and phosphorus. All we have to do is cross the charges, and we get Li3P, lithium phosphide. Potassium and oxygen. Potassium with a charge of +1, oxygen with a charge of -2, and when we cross those charges, we get K2O, potassium oxide. Magnesium and chlorine, with magnesium with a charge of 2+, chlorine with a charge of -1. We cross the charges and we get MgCl2, magnesium chloride. Calcium and oxygen. Calcium with a charge of 2+, oxygen with a charge of 2-, and when they cross the charges, we get Ca2O2. Now, we want to reduce it to its lowest number ratio. So we cross out the 2's. The 2's cancel out since they're both 2's, and that just leaves us with CaO, calcium oxide. Ionic compounds are electrically neutral. That means that the positive charge of the cations cancels out the negative charge of the anions. Let's look at calcium oxide, for example. This is an ionic compound where the cation, calcium, has a charge of +2, and the anion, oxygen, has a charge of -2. Now, when these form a compound, +2 minus 2 equals 0. Therefore, calcium oxide is electrically neutral. For magnesium chloride, the magnesium cation has a charge of +2, and the chlorine anion has a charge of -1. But look, there are 2 chlorines. So +2 minus 1 times 2 will give me 0 overall. And finally, aluminum oxide. The aluminum cation, each one has a charge of +3, but there are 2 of them. That gives us an overall positive charge of +3 times 2 equals +6. Now look at the oxygen anion. Each oxygen has a charge of -2, but there are 3 oxygens. -2 times 3 equals -6. For our overall charge, +6 minus 6 give us a charge overall of 0. It's neutral. We've already learned how to name ionic compounds, but we need to go over the naming conventions for ionic compounds with transition metals, because transition metals often have different charges for each element. Let's take a look at iron, which forms cations with a charge of +2 or +3. Let's look at iron +2 when it combines with the oxygen anion. When we cross the charges, we get Fe2O2, and we know from before that when both of the coefficients are the same, they cancel out, giving us a chemical formula of FeO. Now, how do we say this? We say iron Roman numeral 2 oxide, and you say it that way because the charge of the cation is +2. Iron Roman numeral 2 oxide. Now, what if we were looking at the iron with the charge of +3? When that combines with oxygen, we cross those charges and we get Fe2O3. This will be called iron Roman numeral 3 oxide. The reason being is because the charge of the iron cation is +3. So you have a cation which can form more than one kind of charge. You need to determine what charge it has when you say the name. If it has a charge of +2, then you need to say iron 2 oxide. If it has a charge of +3, you need to say iron 3 oxide. Next, let's look at copper, which forms cations of charge of +1 and +2. Now, let's start with the +2 cation combining with chlorine. When you cross the charges, we get CuCl2. Now, we say this as copper 2 chloride because the charge of the cation is +2. Now let's look at the copper, which is a charge of +1. When that combines with chlorine, we get CuCl, and we would say that as copper 1 chloride. And we say that because the charge of the cation is +1. So whenever there are different charges for the same cation, we need to specify which one it is with Roman numerals in the name. Recalling everything that we know now about ions, the concept of ionic bonding should be simple to grasp by now.
Atoms such as sodium may lose electrons and become positively charged ions. Other atoms such as chlorine may gain electrons and become negatively charged ions. Depending upon their surroundings, the opposite charged ions may attract each other, thus forming an ionic bond.
An ionic bond is formed when a positively charged cation is attracted to a negatively charged anion. Ionic compounds have some distinct properties. For one, they're solids at room temperature and they're usually arranged as crystals. Second, they have extremely high melting point. And third, they can conduct an electrical current when they're melted or dissolved in water.